Yes, good morning, students. Today we are going to discuss about main memory. Okay, main memory is a central storage unit in a computer system, and it is used to store the programs and data during execution. The programs and data that are currently being executed are stored in main memory. Okay, because it is the memory, this is the memory that is directly connected to the CPU. For CPU to execute the programs and the data required for the processing need to be stored in main memory. And the principal technology used for main memory is based on semiconductor integrated circuits. Okay, integrated circuit chips are used to construct the main memory. And this main memory includes the two types of memory, random access memory and read-only memory. Okay, RAM and ROM. This is random access memory, and the ROM is read-only memory. Okay, this random access memory can also be called as read-write memory. Okay, meaning this data can be read from the memory and data also can be written. Okay, the content stored in the memory can be changed by performing this write operation. But this ROM is read-only memory. Okay, so it is only the operation that can be performed on the data stored in ROM is read. Okay, we cannot write into ROM. Okay, so we will discuss more about this. Memory consists of random access memory and read-only memory. So here the fourth point, the most of the main memory in a general purpose computer is made up of random access memory integrated, okay, RAM integrated circuit chips, but a portion of a memory may be constructed with ROM chips. So in the memory, in main memory, or for constructing this main memory, most of this, most of the part of this main memory is RAM, random access memory, the read-write memory. Okay, and a little portion of the main memory consists of read-only memory. And now if we see this RAM and ROM in detail, I already said RAM is read-write memory. Okay, so read, the operations that can be performed are read and write. So the programs that are that may require changes are stored in random access memory. Okay, we need to perform write operation to change the data in the memory, right? That is stored. Okay, or if it is only to read the data, we perform read operation. Okay, if it is to write new data, or to make some changes in the data, we perform write operation. As this RAM is a read-write memory, the programs that are subject to change are stored in random access memory, and the programs that remain unchanged, okay, the programs that remain unchanged are stored in read-only memory. Okay, because such programs are only meant for reading. We cannot make any changes, or they do not require any change. Okay, so those programs are stored in read-only memory. And so here the bootstrap loader program. Okay, when we initially start up the computer, when the power is switched on and the computer starts its operation, the first program that is executed in the computer is the bootstrap loader program. This bootstrap loader is a program that gets executed, okay, initially to booting up the operations of the computer, okay, to start the computer. So when the power is switched on, the program counter is loaded with the initial address of this bootstrap loader program. Okay, so PC will be loaded with the initial address of this bootstrap loaded program, and it starts, the control start executing the instructions in this that start up the computer, okay, to make it ready for the process. Okay, so this is the initial program, and this program consists of standard instructions that does not require any change. It is a standard routine that is executed every time the computer is switched on. So this program is stored in ROM. Okay, it does not require any change. Okay, so such programs, bootstrap loader program and the other programs that does not require any change are stored in read-only memory, and the programs that require changes, okay, that may need to be changed by performing write operation are stored in random access memory or read-write memory. And the other difference between this RAM and ROM are this random access memory or read-write memory is a volatile memory. Okay, means the contents of this RAM are destroyed when the power is turned off, and ROM is non-volatile. Okay, because here the programs and data that are stored in ROM will not get erased. Okay, or the data and programs remain unchanged when the power is turned off. Okay, so this memory ROM is non-volatile and RAM is a volatile memory. Okay, so that is this is how the main memory is designed. Main memory consists of the random access memory and read-only memory. In random access memory, the operations performed are read and write. So the programs and data that are stored in RAM can be changed. Okay, but ROM, the programs and data that does not require any change are stored in ROM because the operation performed is only read. Okay, it cannot be written. The data or program cannot be changed. Okay, one of the program that is stored in ROM is bootstrap loader, that is loaded when the computer is switched on and to perform the initial operations to start up the computer. Okay, and the other difference we discussed is RAM is volatile. It is the data and programs are erased, okay, or destroyed when the power is turned off. But in ROM, the data and programs remain unchanged. Okay, the contents of ROM remain unchanged when the power is switched off. So it stores, okay, in other way we can say that ROM stores the data permanently and RAM stores it temporarily. Okay, random access memory or read-write memory stores the data temporarily, and ROM, okay, is used to store the data and programs permanently. Here is a block diagram of a random access memory chip. Okay, here figure A shows the block diagram of RAM chip. The capacity of this RAM is 128 by 8. Okay, that means this RAM has, it can store 128 words. Okay, and each word having 8 bits. 128 words, each word having 8 bits. 8 bits of data, that is a byte of data. Okay, that is that's the capacity of this RAM. And so if this RAM stores 128 words of data, how many bits are needed to represent the address? The RAM that stores, okay, 128 words of data, how many bits are needed to represent the address? Yes, somebody wrote the answer 7. Yes, 2 power 7 it is. Okay, so 7 bits are needed. 2 power 7 is 128. So we need 7 bits. 7 bits are needed to represent the address of this memory. Okay, so here the address line has 7 bits. Okay, that is why it is represented as AD7, 7 bits of address. Okay, and the control line CS1 and CS2. Okay, these two control lines are used to select this RAM. Okay, the particular RAM chip. Okay, this I will explain in detail what are these select lines, okay, in this slide. Okay, now here this chip select 1, and there are two chip select lines, CS1 and CS2 bar. Okay, these are used to, so here this means CS2 bar means if the input is 1, it is 0. Okay, it generates 0. If it is 0, it generates 1. Okay, so these bits are used to select the particular RAM chip. The computer may have more number of RAM and ROM chips. Okay, if that depends on the storage requirement of the computer. Depending on the requirement of the storage, the number of chips, okay, RAM and ROM chips are combined to form the required memory size. If one RAM chip is not sufficient, okay, if the computer requires more memory, it's not only 128 words. If the computer, okay, if we have to store more data in the computer, more RAM chips are combined to form the memory. Okay, so from out of all those RAM and ROM chips, one has to be selected for performing read or write. These are the two control lines for performing the operations. In RAM, it is read write memory, correct? So the operations performed are read and write. So we have two control lines, read and write. Okay, this is enabled. Read line is enabled by the CPU to perform read operation. So this is the input operation. This is the input operation that is performed, and this is output. Write is writing data into this RAM. Okay, and read is sending data out of the RAM, output data from the RAM. Okay, so these are the two control lines, read and write, are used to perform the read and write operations. Okay, by performing this write operation, the contents of this memory can be changed. Okay, reading here means the data from this RAM is read by some other unit. Okay, so these are the two control lines, read and write, okay, are used to perform these operations. And address line we discussed, this is to, this carries the address, and here we need a 7-bit address as this memory stores 128 words. And these control lines, we have two control lines, these are to select the particular chip. And the data bus is 8-bit data bus, okay, because each word size is 8 bits here. So to carry this information, okay, when a word is being transmitted out of this RAM or into this RAM, okay, that is taken through this data bus, right? That is carried by this data bus. So it is a 8-bit data bus. And here you need to note this data bus is bidirectional. Why is it bidirectional? Because the operation performed is read and write. For reading data, this line, okay, it is taken from the RAM. It is an output operation. Okay, so the data is placed in the data bus that is taken out, okay, out of RAM. And for writing data, the data that is coming from the other unit is written into this RAM. Okay, so here we have a bidirectional data bus. And this table below shows the function of this RAM. Okay, let's here say that CS1 is 1 to select this particular RAM. Okay, let's say this is RAM chip 2. Okay, let's say that this is RAM chip 2. And to select this particular RAM, the CS1 should be 1 and the value of CS2 is 0. Okay, the combination of these two select lines, 1, 0, select this RAM chip. Okay, RAM 2. So the function table here, we have the inputs, control inputs, CS1, CS2, read control, write control. Okay, and based on this, based on these two controls, CS1 and CS2, the particular chip is selected, memory chip is selected. And based on this read and write controls, the operation is performed. Okay, either read or write. And depending on this, the memory function, okay, memory functions depending on these chips. And here we have the state of the data bus. So first case, when CS1 is 0 and CS2 is 0. Okay, we said that 1 and 0 select this particular RAM chip. Okay, so 0, 0 means this will not select this RAM. So the operation cannot be performed because this is not, the RAM chip itself is not selected. Okay, CS1 and CS2 are not 1 and 0. Okay, so we don't consider this read and write operation. The memory function is inhibit, means it will not function. Okay, it will not perform any operations, and the state of the data bus is in high impedance state. There is no output. Okay, the lines are disconnected here. There is no logic significance. And when CS1 is 0 and CS2 is 1, okay, it is not 1 0 here. So this also will not select this RAM, and read and write are not considered here. Okay, whether it is 1 or 0, it doesn't matter because it is not, the RAM is not selected, and memory stays in inhibit state, and the state of the data bus is high impedance. And the third case here, 1 and 0. Okay, means the RAM selected is this particular RAM is selected. CS1 is 1 and CS2 is 0. This select this RAM. And when read is, we now see the read and write lines. Read is 0, means it is not enabled. There is no read operation required. And write is 0. Okay, so this is also not enabled. Okay, here the operations are all disabled, means there is no read and write required. So memory again stays in inhibit state. Okay, it will not perform any operation, and the lines are put in high impedance state. And next case, CS1 is 1 and CS2 is 0. Read is 0. Read is not enabled, but write is enabled. Okay, the write control, if you see, this is enabled. This is 1. Okay, this means the memory has to perform write operation. So the operation the memory performed is, memory function is write. What is this write means? Input data into RAM. Okay, that is writing data to RAM, taking input. Okay, through the data bus, the data is taken into this RAM, written into this RAM. And the next case, 1 0. So this RAM is selected, and the operation that is enabled, the control line enabled is read. Okay, it is 1. And write is, then when this is read is enabled, write will not be checked. We don't see if it is 0 or 1. Computer has to perform this read operation. Okay, so the RAM function is read, means it sends the data. Okay, some other device read data from this RAM. Okay, RAM places the data into this output bus, in the data bus. And the next state, 1 1. Okay, so here CS1 is 1 and CS2 is 1. It does not select this RAM chip. So this will not be, read and write will not be considered. Memory is in inhibit state, and lines are in high impedance state. Okay, this is the function table to describe the selection of a particular RAM. Okay, if it is selected, and how this read and write can be enabled to make this RAM perform a particular operation, read or write. It is a read-write memory. So we have both this read and write operations here with the two directional data bus. And the second part of this memory is read-only memory, right? A little portion of memory is made of read-only memory. And here, this is a block diagram of a ROM chip. And the size, capacity of this ROM is 512. Okay, 512 words, each word having 8 bits. So how many bits are needed to represent this 512 words? How many bits of address line?
9.
9 bits, correct. So we have 9 bits. Okay, in the address line, 9 bits are used to represent this 512 word memory. Okay, address of this 512 word memory. And the chip select we have here are the same, like RAM, CS1 and CS2, to select this particular ROM, depending on the value, 0, 1 or 1, 0. Okay, one particular value, a combination of this, select this ROM chip. Okay, and we have a 8-bit data bus. And here this ROM is read-only memory. Okay, it will not perform write operation. So we don't have the control signal. By default, we don't have read and write as we had in RAM. Okay, these lines are not there in this. Okay, because by default, the operation is read. Only read is performed. Okay, there is no option of writing data into this. So as it is only reading, means reading is output, right? Sending data to the outside units. Okay, so here we have a single one directional. It is not bidirectional here. Okay, as I said, depending on the storage requirement of the memory will have number of ROM chips and number of RAM chips, okay, combined. Number of RAM and ROM chips are combined together to form the memory, actual main memory. So let's see how the memory is connected to the CPU and how the CPU, the communication between the CPU and this main memory is done. Okay, here, this is the memory. Okay, here we have this part is our main memory, and here we have the CPU. The two units shown here are the main memory and CPU. Main memory consists of RAM 1, RAM 2, okay, all 128 by 8, 128 words with 8 bits, okay, in each word. And RAM 2, RAM 3, RAM 4, okay, there are 4 RAMs and 1 ROM chip, okay, with 128 by 8, means this ROM also can store 128 words and each words of 8 bits. Okay, this is the main memory that has this 4 RAM chips and 1 ROM chip. And this data bus, okay, you can see the, I think, clear this. Okay, this is our main memory. All these chips together, makes the main memory. And data bus. Okay, data bus is to carry the information between this memory, main memory, and the CPU. Okay, the CPU uses this control lines, read and write, okay, to instruct the memory to perform the operations of reading or writing. Now, if you see this write line, write can be performed only in RAMs, okay, not in ROM. ROM, the data cannot be written in ROM. So here you see this write line. Let me highlight and show you this. Okay, here we have a write line, and in RAM 2 it is connected to these, okay, control lines. And here we don't have, in ROM we don't have a read or write line because the only operation that is performed is read. Okay, so this write is connected as the control input to all the RAM chips. And this read line, okay, read line is also connected as a control input to all the RAM chips here, and the same line here. Okay, all the 4 RAMs has this read input. Okay, so when the read operation is performed, this is enabled. Okay, this will be 1. And when write operation is to be performed, this will be the write signal. Okay, this control will be 1. Okay, so this way the CPU controls the operation that is performed, okay, in memory, whether it is read or write. And here we have the address bus. Okay, CPU has the control lines here. These are the control lines, and this is the address bus. And here we have a data bus. This is the system bus through which the data and the other address and control information are transferred, okay, between these units, through which CPU controls the operations. Okay, data bus is to carry data between this main memory and CPU. And address bus is to select the particular, this includes the bit that select the particular chip, okay, memory chip, and specifies the word, okay, the particular word in the chip, okay, the location, exact location in memory where the data to be written or read from, and whether it is ROM or RAM, all these are decided by the values in the address lines. these read and write are to control the operations. So now let's see this address lines. Okay, address line, in the address lines, the least significant bits 1 to 7, here this line, the least significant bits 1 to 7 are connected as the 7 bits. Okay, least significant 7 bits are connected here to RAM 1 and here to RAM 2 and to RAM 3, RAM 4, and here it's actually 512. Okay, this ROM capacity of ROM is 512 memory words. Okay, 512 words by 8 bits per word. So here these 1 to 7, least significant 1 to 7 bits are connected, okay, to this, the first, for the first 7 bits of address lines. So this address, it has 9 bit, right? 9 bits in the address line. So 1 to 7, the least significant 7 bits are these 7 bits. And 8 and 9, okay, from this address bus, the 8, line 8 and 9, okay, you can see this path here. Okay, so 8 and 9 are connected as a 8th bit in the address line and the 9th bit in the address line. Okay, because it requires 9 bits in the address line to represent the address, the memory word of the memory that has 512 words. So we have 1 to 7 bits of least significant 1 to 7 bits of this, okay, that is connected to all the RAMs that are 7 bits address, 7 bits in the address line, and 8th and 9th bit are also connected here, okay, which is not connected to the RAMs to represent, for the 8th and 9th bit of the address line. And here this 8th and 9th bit for these RAM chips, okay, 8th and 9th bit, the 8th and 9th bit may be, the combinations may be 0, 0, or okay, this is 8th and 9th bit, or it may be 0, 1, or it may be as 2 bits. Okay, when we take 2 bits, they can represent 4 different combination. Okay, they can be used to represent 4 different combinations. So 1, 0, 1, 1. Okay, but these 4 values are used to select one of the RAM chip out of these 4 RAMs. RAM 1, RAM 2, RAM 3, and RAM 4. Okay, so we have 2 inputs, but the output is out of 4, we need to select 1. Okay, so we need a decoder circuit here. Okay, decoder is used. It is a It is a 2 by 4 decoder. Okay, it takes 2 inputs and generates 4 outputs, because we need to select one out of 4 RAM chips. Okay, from these 2 inputs, 0, 0, the inputs may be 0, 0, 0, 1, 1, 0, or 1, 1. This 9 bits, 9 and 8. Okay, so these 2 bits are connected to this decoder, and it generates, decoder circuit takes n inputs and it generates 2 power n outputs. Okay, so here 2 inputs and it generates 4 outputs. Okay, the output of this decoder are 0, 1, 2, and 3. The 0 represents, okay, the 0 line is connected to CS1. Okay, means it select RAM 1. And 1 output of this decoder is connected to CS1 of, means the chip select line of RAM 2. So this selects, if the output of the decoder is 1, means what? The bits 9 and 8 are 0, 1, this combination. Select RAM 2. And if the bits are 1 and 0, if the bits 9 and 8 are 1 and 0, it select 2. The decoder output will be 2. Okay, it selects the chip select, means it is connected to the RAM 3, right? The first chip select line of RAM 3. So it select RAM 3. And if the decoder output is 3, it selects RAM 4. Okay, so this way, this 8 and in the address lines, 8 and 9, bits 8 and 9 are used to select a particular RAM. okay, out of these 4 RAMs. As we have 4 RAMs, 2 bits are used for this. If there are more number of RAM chips, here we need to take more, if suppose there are 8 RAMs, okay, then these 3 bits, 10, 8, 9 and 10 will be used in the address bus. 8, 9 and 10 will be used to select one of the RAM chips. And line bit 10 here. Okay, what is this bit 10? We have seen 1 to 7 bit of address bits, least significant 1 to 7 bits of the address bus, and bits 8 and 9. And now about this 10th bit. 10th bit is, okay, connected as the second. Okay, this is the 10th bit, 10th line. It is connected as the second input, okay, second selection input, CS2. Here the complement is done, okay, CS2 bar means if the 10th bit is, we are talking about the 10th bit. If the 10th bit is 1, when it is complemented, CS2 will become 0. And if the 10th bit is 0, when complemented, it becomes 1. Okay, so depending on the value of 10th bit. As we have 1 bit, it is used to select 2. Okay, means this line is used to select either RAM or ROM. Here 10th bit is used as CS2. So if the value of this is 1, if 10th bit is 1, the value in the 10th bit is 1, CS2 will be 0. Okay, here you can see it is connected as the second control input. So here it will become 0 and this is 0 and it is connected to RAM 4 and this value will be 0 and the same is connected here and complemented. Okay, here we have an inverter circuit. It is 1, then complemented here 0, and when complemented here the input is 1, when complemented 0, and again CS2 bar. Okay, so what will be the value here? 1. Okay, so we say that when the bit 10 is 1, when CS2 is 1, ROM is selected. When CS2 is 0, RAM is selected. Okay, that is based on the value in 10. And if it is 0, okay, when the first RAM, what would be the CS2 of this RAM? It becomes 1. Okay, because input is 0. I said the 10th bit is 0. So this case it is when complemented, all this becomes 1. Okay, so when CS2 is 1, RAM is selected. And here the input is 0. This line input is 0 and when complemented it is 1. When again complemented CS2 bar it is 0. So this is not selected, this case, when 10th bit is 0. So 10th bit decides the part of memory that is selected, either ROM or RAM. And here 6 to, it is a 16-bit address line. Bits 11 to 16 are not utilized. Okay, not used. That depends on the number of bits in the address lines that are used depends on the number of size of the memory. Okay, number of chips used and the capacity of each chip, RAM and ROM chip. So when this control lines, talking about control lines, when the read line is 1, the operation performed is read operation. Okay, in the selected chip, RAM or ROM chip, this address lines are used to select a particular RAM or ROM chip. And then this is checked. Okay, the control lines are checked. If read is enabled, read operation is performed. If write is enabled, write operation is performed. And once, if suppose the operation that is initiated, let's now assume that RAM 1 is selected. Okay, here 8 and 9 bits are 0 and 0. Okay, so this case the decoder output would be 0. Okay, when 8 and 9 bits, 8 and 9 are 0 0, decoder output is 0. So here this is selected. Okay, CS1 is active here and CS2. Okay, let's say the 10th bit is 0. So when complemented, it became 1. So these two lines are 1, means the chip selected is RAM 1. And CPU places this, activates this read control. Okay, so read control is 1. So what the RAM does, it is an output operation. Okay, it is the CPU wants to read data from this RAM. So RAM places the data, and address information is also sent by the CPU. 1 to 7 bits of this address line specify the address. What is this 7 bits of address? Out of these 128 words, the particular word, okay, that is selected. So this RAM places the word, okay, memory word that is specified by this address into the data bus, okay, and that gets transmitted to CPU. Correct? And if suppose the operation that is performed, okay, the CPU enables this write line. CPU has some data to write in this memory. Okay, so that case CPU enable the write line and this becomes active. Okay, when write is enabled in the particular address, okay, the address specified by this AD7, these bits, the word that is specified, okay, selected in this particular RAM. Data from the bus is loaded into this, okay, transferred and written in that place, okay, in the specified location. Okay, memory address map. Memory address map is a pictorial representation of, okay, the assigned address for each chip in the system. The pictorial representation of the assigned address for these chips in the system is called memory address map. So here we have discussed, right, the address. So we consider these address bits 1 to 7. There are 16 bits, but utilized number of bits that are used are 10 bits. So let's write these 10 bits here. 10, 9, 8, 2 and 1. And let's take RAM 1. If we take RAM 1, the components here are RAM 1 and RAM chip 2, 3, RAM 4, and there is one ROM. So as the capacity of these RAM chips are 128 watts, these 7 bits are utilized for specifying the address of these words. Correct? Okay, so let me mark it. These are the address bits that are connected to these RAM chips, and the 7 bits here, the 7 bits are connected to RAM 3. Okay, least significant 7 bits. This 1 to 7 in the address lines, 1 to 7 we are talking about, are connected to RAM 4. And how many bits are connected to read-only memory? Here we need 9 bits. Okay, so including this 9 and 8 bits. The least significant 7 bits. The least significant 7 bits plus line 8 and 9. Okay, these are also connected as address lines to this ROM. And here 9 and 8 specifies what are these 2 bits for random access memory. These 2 bits are to select, this is CS1, right? To select a particular RAM chip. RAM 1, okay, it is to decide whether the memory selected is RAM 1, RAM 2, RAM 3 or RAM 4. That is decoded, and our decoder output 0, if it is 0, RAM 1 is selected, and if it is 1, RAM 2 is selected. Okay, if it is 2, RAM 3 is selected, and if it is 3, RAM 4 is selected. So these bits, the combinations may be 0, 0. This select RAM 1. And when 8 and 9, the bit combination are 0 and 1, they select RAM 2. And 1 0 select RAM 3, and 1 1 select RAM 4. Okay, and 10th bit. Okay, what is this 10th bit? This decides which component of the memory is selected. Okay, CS2, 10th bit is connected to the CS2 input of this memory chips. Okay, CS2 bit may be 1 or 0. If it is 1, means when it is active, okay, it is 1. So the memory, yeah, when the CS2 is 1, then that particular memory component is selected. Correct? Okay, so when the 10th bit is 0, correct? When complemented, it becomes 1. RAM chips are selected. Okay, that represents the selection of RAM. And when this 10th bit is 1, it select ROM. Correct? When it is 0 here, okay, in the diagram, when it is 0, when complemented, here it is inverted already. So the input given is 1, and when CS2, when it is complemented 0, okay, so it is not selected. And when the input is 1 here, when complemented 0, and then again complemented and it is 1. So this case, when the value of bit 10 is 1, this is selected, ROM is selected. Okay, so the 10th bit should be 1. So this is the memory address map. Okay, so memory address, the map is this is a pictorial representation of the assigned address space for the chips, okay, the memory chip in the system. Okay, so memory unit, main memory, it is the central storage unit of a computer system, and it consists of RAM and ROM, okay, read write memory or random access memory and read only memory. In read write memory, the operations that are performed are read and write. Okay, read and write operations can be performed, but read only memory, only data can be read from memory. So here the data that does not require any change are stored in ROM, read-only memory, and the data or programs that require changes are stored in random access memory, okay, because it allows write operation to change the data. And ROM is a permanent memory, okay. It is a non-volatile memory. When the power is switched off, the content stored in memory remains unchanged. But RAM is a volatile memory. When the power is turned off, the content stored in RAM will get erased, okay, will be destroyed. And we have seen the block diagram of random access memory with 128 words and each word having 8 bits. The control lines are used to select the chip, okay, select the particular component of the memory and read and write to perform the operation. Okay, these lines, control lines are used by the central processing unit to instruct the memory, okay, what is the operation, whether it is read or write to be done. And this address line is used to select the particular, to locate the particular word in memory. And here is a function table. And read only memory, the same way, here we have the selection lines to select the component, and address lines, as it is a 512 word memory, we have 9 address lines. And there is no read write control because always the operation performed is read, and the data bus is in one direction because only the data can be read from this memory. It cannot be written. So there is no write operation. And here we have seen the memory connection to the CPU and how the CPU uses these lines, okay, data bus to transmit data, and read and write lines to control the operations of the memory, and address lines to select the particular component, either RAM or ROM, and from within that, okay, the particular chip. There may be a number of RAM chips and number of ROM chips. To out of that, to select one chip, these lines are used, and in that selected chip, the location, okay, AD7 and AD9 is to select the particular memory, okay, memory word. This way, the address lines are used to locate it, okay, locate the data. If you have any doubts, you can clarify. Let me check the attendance.